too as well. Okay, welcome to October the 20th, Thursday night, on our second study night in regards to studying for the UAV workshop to pass the knowledge test that's out there. Okay, so here what we have joining us today will be helping me. I'm going to try to do play-by-play, and I'm going to have Will Evans help us out with the color. And who we have on? Will, why don't you go ahead and say hi?
Well, hello. My name is Will Evans, and it's a privilege to be invited to help Stephen Gowdy out with this.
Excellent. Our attendees today, we have myself, Will Evans, Zach Gowdy, and then we also have for our attendees will be Dwight Anderson and Josh Dykstra. And I'm going to go ahead and just ask Josh and Dwight to go ahead and say hi. I'm going to send out an unmute item for those guys if they can. Josh, are you there?
Yep, I'm here. How's it going?
It's going great. Thank you very much. Appreciate it. And Dwight, are you here?
Yep, I'm here, ready to go.
Excellent. I'm going to go ahead and mute you guys if that's okay, and I'll leave Will on to add some commentary. And we're going to start off. Dwight, we did miss you yesterday, and there were a lot of things that we went through, some introductions for myself and for Will. Let me go to my presentation so it looks a little better here. And we also then looked at what we're going to talk about in our workshop. Overview of concepts, the materials, examples, practical life, real life scenarios, and then we're going to talk about questions. The great part along the way is if perchance you have a question, Dwight and Josh, over in the little box, there's a little box to the right. It has a little hand. You can raise your hand, and if you have a question, and Zach is going to be... What stuff's not showing? I need to show my screen. Can I show all screens? Maybe that would work better. So if you can see, can you see my... You want to see the right screen? Let's go over to this one, see how we're doing it. If you take a look here, you'll be able to see, take a look at the, I have two screens. I'm on, which screen am I sharing? I'm on a share second screen. Okay, I'm there. And then what's happening here is that if perchance you have a question, then right here at this, how come my arrow's not working so well, is that right here, you can press and raise your hand. If you have a question, you get to unmute yourself if need be. Not sure what that does. Maybe pause the screen. I'm not sure, 100% sure. But in this particular setup, all you have to do is raise your hand. So why don't we go ahead and just test that for right now. Dwight, why don't you go ahead and just raise your hand right here if you can. Excellent. I see that. And Josh, why don't you go ahead and raise your hand. Excellent. You guys can put them all down now. Excellent. Now, if you have a question or so forth, go ahead and raise your hand. Dwight, I'm going to go ahead and put your hand down. See you there. And if you have a question, then you can either, you want to stop or ask that question right then and then, you can raise your hand, or you can enter the question in the question box right down here to the right. If you can see that, you can enter a question, okay, where it says Dwight's already there and he can figure out, then Zach will be able to respond to those questions as needed, okay? So I think we'll be good on that. So those are two ways to interact with us as need be. We'll try to keep an eye on what's going on in regards to the questions and the raised hands, and go from there. Excellent. So that's kind of the first part of it there. I'm going to go ahead and move through some of these slides that we kind of went through already. And Dwight, we'll go through this one more time with you a little bit later and take a look at some of these things in regards to the initial regulations. But I wanted to kind of go through some of the things that we're going to talk about today. You know what? I'm going to talk about this since we didn't really talk about it so much. And I want to talk about when we as pilots make decisions, we have to make a decision based upon the information that's at hand. And it's called, we call this a ADM, which is, what's our definition for ADM? Aeronautical decision making. Here it is, aeronautical decision making, where we take a look at the situation, figure out what our options are, choose and make an action right away and evaluate again around the situation. But part of this that the FAA wants to ask a question about is that, do we understand the psychological factors that go into this? Such as if you have a an attitude of anti-authority where you don't need to follow the rules, you don't like the idea that people are telling you what to do, you don't like the idea that regulations are over your head, and so you end up, don't tell me what I need to do, I'm going to go ahead and just fly my drone. Well, the issue happens to be is there's a lot of hazards that become of that. And the antidote to that is you need to follow the rules, because the rules are set up for a reason and they are there to help protect you and to others around you. So remember that anti-authority in some places may have its place, but in the aviation world, it does not have a place. Impulsivity, being impulsive in such a way that, hey, let's get this all done, let's get this wrapped up and let's get it out of here, and you don't stop to think about all the things that could go wrong. And the antidote or the antithesis to that is that you need to understand, not go so fast, think first. One of the things we used to say in construction was safety first, no matter what. And the other one here we have is invulnerability. It won't happen to me. It doesn't happen to me. Don't worry about it. I can basically do the things I need to do because it happens to other people, but not at me. And they don't look at the risks that are there. The antidote to that is you have to think to yourself, hey, this could happen to me. My battery could be only half charged and I could only operate at a certain amount. So make sure that I am taking a look at my battery as I go along. There's two more I want to take a look at, which is being macho. I can do it, and I'll show them. I'm the guy. And so the antidote to that is taking chances that that would lead to foolish behavior. So we need to make sure that you understand that we can't always do everything. We need to make sure that we follow a pattern that is shown to follow the rules. And resignation. What's the use? What's that? What's that? The Eeyore and oh boy,
Oh, bother.
What?
Bother.
Oh bother.
Oh, bother.
Is that what he says? Eeyore, basically the end result is that it's oh no, it's all going to happen to me. It doesn't matter anyway. My drone's going to crash into the water. So you can't take that type of attitude, and that you can make a difference. You can apply things that make a difference in regards to your approach to safety. And let's go right into the regulations here so you can just kind of see this a little bit quicker, and so forth. Will, do you have a second you want to just share anything on this particular thing, on the hazardous attitudes that we could have that could affect flights?
Yes, especially if you're under the authority of somebody else. For instance, if you're flying your UAV, but the pilot in command is actually the one in charge, and if they're telling you to not do something or to possibly do something a little bit different, you need to listen to them, and you need to have a very accepting attitude in that maybe you don't do it the best way, and refer to their expertise and authority. And so you definitely need to have the ability to be adaptable and to know that you don't know everything about this.
Good analysis. Zach, do you remember any of the questions that you had in regards to that were on the test for these?
Yeah, I definitely had the machoism one.
The machoism, I can do it.
And then there was another question about just ADM in general. How
Okay.
I actually walk through.
I had a question on my test, and it was impulsivity. And it said like this. It said, you were working for a local TV station, and the program manager wanted you to go ahead and get the shot as quickly as you possibly could. don't worry about. And so they wanted me to identify what the hazard attitude was, which was impulsivity, and the antidote was not so fast, think first. So while we're on this, I'm going to go to the next slide, and I'm going to pull up a poll. This poll is going to be just kind of a question based on a review from yesterday for Josh. But here's what it is. Here's the poll we're going to put up there.
Tuesday, 2 days ago.
2 days from Josh. So this poll is: what's the antidote when a pilot has the hazardous? What is the antidote when a pilot has the hazardous attitude of invulnerability? So what's the antidote when the pilot has the invulnerability? Okay. So do I have both people? How do I know if both of them voted? All I have is 100%. 50% have voted. So we're still waiting for one more person to vote. This is either Dwight or Josh. Have you voted yet? Still waiting on a vote.
It's okay. Yep.
I'm going to wait. I'm going to keep the polls open for 5 more seconds. Dwight, are you there? Did you vote? Let me unmute you. Dwight, did you get a chance to vote?
Oh, sorry, I just stepped away. I had something I got to do. I'm just back now. What's the question? Antidote?
What is the antidote when a pilot has the hazardous attitude of invulnerability? And we just covered that when you were outside the room.
Okay.
I got this picture of Will looking right at me. Do you see that? He's looking right at me.
Okay.
It's only the polls. They can only see the
Oh, they can only see the poll? Oh, they can't see. Okay, gotcha. Okay, I have 100% of the people that have voted, so we'll take a look and see how we're doing here. Let's close the poll, and now I'm going to share the results. And the results are, yes, 100% of the vote of the participants voted and got it right. What's the antidote when a pilot has the hazardous attitude of invulnerability? It could happen to me, is what you have to think through. Very good, because there'll be at least 2 of these questions on the test there, and Dwight, I'm going to go ahead and mute you here if that's okay.
All right.
You're muted. Okay, and we'll hide the results. Okay, let's go back to our screen sharing side. Am I there already? What is it showing? Is it showing this? There we go. Okay, can you see it, Zach? Is that good? Okay. Okay, we already talked about psychological factors. I think we're pretty good with that. Let's keep on moving on. And then we talked about this and so forth, analyzing yourself and what could prohibit you from actually flying your drone. And the thing was 8 hours bottle to throttle, or in our case, bottle to controller. So you cannot have consumed an alcoholic beverage more than 8 hours ago from the time that you took a drink or they saw you at the bar until you actually are at the controls. And you cannot have a blood alcohol content greater than 0.04, which means that you still could have drank 9 hours ago, but your blood alcohol concentration could be up there. So, okay, we talked about some of these issues. Let's keep on. We're going to move through, Dwight. We're going to move through some of these questions. And I'm going to ask you this one here. Here's a test question here. Because this one was on the test, and almost everybody I've talked to has received this test question. A conviction for the violation of a federal or state statute relating to the growing, processing, manufacture, sale, disposition, possession, transportation, so forth, so of marijuana, narcotic drugs and marijuana is grounds for denial of an application for a remote pilot certificate with a small UAS rating for a year of up to 1 year after the final date of conviction, or they can be suspended. So the question that I had on my test was, so after the conviction of marijuana, how long do you have to wait before you can get your remote pilot certificate? A was 6 months, B was 12 months, and C was 18 months. And the correct answer, as you all understand here, is 12 months or 1 year. So very good. I am safe. You just have to remember this. Make sure you understand when analyzing your own self-assessment. I am safe. Illness, medication, stress, alcohol, fatigue, and emotional state. Just make sure you keep that there because it will be a question on the test. Okay, we already went through airspace. Bear with me here. I apologize for going through this so fast. But I'm going to get to the piece we're going to talk about today. Dwight, we'll get back to you on a little more of the airspace, okay? Okay, I do want to talk a little more about sectional charts and what we were going to talk about yesterday. And I want to kind of, when it's all said and done, I want to kind of show you some sectional charts and look and make some decisions in regards to these things. So let's do this. Let's go ahead and if you have downloaded this book, the supplemental guide, this is the Airman Knowledge Testing Supplement. If you've downloaded this off to the right in the handout portion, let's go ahead and turn to a page. Let me see if you've got it. Go to, let's just pick one out here that we can go to that would be advantageous for us to look at. I'm going to pick one out here that I know of already. Actually, what is this we're looking at here? This is, let's skip to one that I've got. Bear with me here 1 second. Is this where I'm supposed to be doing this, Zach, or is this a little bit later in?
Which one are you talking about?
I'm just going to go through some of the charts. Oh, well. You know what? Let's just...
I mean, those are at the end. But
they're at the end?
you can choose wherever you want.
Well, you know what? Hold on to that for just a second. Let's mow through these slides, and then we'll get to it as we get a little further. I apologize for making this a little... Coming back. Let me go over this a little bit area. Some of the areas that are there are put in a restricted area, as you can see here. A restricted space, so you need to make sure you look at each one of the that used to be the sectional charts, and over to the right it'll look at it'll say R4401 A and B, and it'll tell you specifically when those are being operated on. And as it is, it's Camp Shelby, so there could be things that are going on in that particular area. A different area here too as well, a warning or prohibited area. Same thing here. You have to look at the number and correspond to what those numbers are and what's going on. Different warning areas that might be going on. It could be fire type arrangements or things like that, or training that's going on there too as well. In this particular one, high volume of helicopters, rotary and fixed wing flight training in this particular area. So you need to make sure and take a look at what that is, A211. So you go over and take a look at what that is. Some of these areas are controlled CFAs, controlled firing areas, where tanks are going on. Tanks are shooting off right there, and then they'll close down. They close down the airports. The tanks fire. They open up they stop firing, and then they let the airport run. So where activity is suspended, and so forth. So you need to understand what's going on at each one of those locations where it mentions it on the map. So anytime you have those pictures or those designation that are there, gives you an idea. Let's take a look at, I think, the sources for airport data. I think this is really important for us to take a look at this. We have information we can get from different aeronautical charts. Sometimes you have charts that are for highly populated areas, but most everybody will be using the chart supplement, which is typically or formerly called the Airport Facility Directory. Will, when you flew, did you have the Airport Facility Directory with you?
All the time.
All the time. I'm in the exact same boat. I never left anywhere without having a copy of it with me. Let me see if I can pull up one here, but go ahead. It was one of those things that just, it's a mandatory thing you have with you.
You just have to have it. There's no way around that.
Right. This the chart supplement, the older ones look like this. Now they're electronic, but in this particular case, it's a small little book, and inside the book it would have it would have airport data. Right? Will?
Yes.
Which would, go ahead. You go ahead.
What's that?
Well, it's okay. I was getting, in that airport data, we'd have basically the information. It would tell you which runways may be active, what is the pattern of the runway, there might be a telephone number in there if you have something special, what the control tower hours of operation happen to be, how long the runway happens to be, the elevation of the runway, and any different factors that may be going on there, special factors, much as if it's lit up by lights. How do you control the lights? There's a way you can control the lights from the sky, things like that, if perchance it's an uncontrolled airport. Anything else you want to add there?
Not that I can think of. I mean, I mean, it definitely, what that won't have in there is the NOTAMs, which is just a mandatory. You have to check that for sure.
Good point, and that's the next point in here, the notice to airmen's. Basically, if perchance things are going on, and also temporary flight restrictions that you need to find and so forth, notice to airmen may be something in the area of, there may be specialized traffic that's going on, or maybe there's a parachute contest that's going on in your particular area, and you want to be well aware of it when flying your UAS. And also, a lot of information can be received from the Automated Terminal Information Service, ATIS. ATIS is when you're approaching a particular airport, you can always call into ATIS and listen to that particular frequency to find out what is going on, weather, and also if there's a special activity, they can give you also different information that's there. Very important. These are so on the test, so let me apply this to actually the test, they'll ask you some questions. Common source of information. If I wanted to know what frequency or how long a runway was, I could go to the supplemental chart because here it is. Formerly, the Airport Facility Directory has a listing of all the airports that are there. If I needed to, we'll talk about some more, but that was one that, keep in mind, there will be up to two questions that will be about the Airport Facility Directory or the supplement, actually called the chart supplement, they call it. Even though there's not charts in there, it'll have schematics of the airport. Okay, there are two types of airports or towers that are out there, towered and non-towered. A vast majority of the airports out there are non-towered airports, but obviously as you get busier and busier, then they become controlled towers, and they need special attention as we operate closer to these particular airports. Okay, let me move on here to air traffic control. ATC is one of the things that we actually have to work within. ATC has local jurisdiction over each airport or each jurisdiction that's there. The Air Traffic Organization in Washington, D.C. oversees ATC, and they're part of the FAA, but the ATC locally has the power to orchestrate flights, and it's their responsibility to make sure there's separation between aircraft and manned and unmanned aircraft. Okay. What else can I say here? Most of the time, there's two-way communication between each one of the airplanes that are out there, and there may be some requirement as we move forward, but at this particular time, they're not set up for UAS pilots to be able to communicate with the tower. So, but it would be worthwhile for you to learn how to communicate on what's called a NavCom radio, so that you can communicate to the tower or to other aircraft in the area if it needs. Let's go on.
Can I mention something there,
please,
Steve, about the local ATC?
Yes, please.
I have had some clients when I'm instructing them on how they need to conduct their NOTAMs, getting approvals at your different airports and things like that. I have had some clients say, "Well, I already got it. I already got approval from the FSDO," which that's fine, but you can't. Every single airport, you need to make contact with that airport authority, whether it's a controlled airport or it's an uncontrolled airport. You have to make contact with that particular or individual airport authority. which if it's a controlled airport, then that is going to be their tower and local ATC there. It doesn't matter if you have received approval from your FSDO, because the local airport authority and airport ATC, they can actually trump the FSDO based on their particular operations. So you have to make sure that you always get or make contact with that particular airport authority wherever you're going to be operating.
And that's exactly right for aircraft and so forth. Now the rules are changing as we go further, in that they do want eventually with Part 107 is that we would not talk directly to ATC, but we would file a waiver for operating inside Class B, C, and D and E to the surface. But what Will is saying is completely right, and I think there's going to be a phased transition period over the next 2 to 3 years where we may have a combination of talking to ATC and then talking to the ATO out of Washington, D.C. Thanks, Will. That's excellent stuff. Let's go right on to understanding latitude and longitude. So as many of you look at the globe and you take a look at it, it's pretty simple in that they've organized latitude and longitude lines. So just so you can remember kind of easier for yourself, latitude lines circle the Earth around the equator. And so they go north and south of each one of those, that runs east and west. My helpful my little brain, whatever we call this thing, right? Little brain food that I have is that latitude is like a ladder. So you're climbing up the ladder. So as you're going up on the rungs of the ladder, those rungs are going around the Earth parallel to the equator. So I'd say ladder goes up, and that's what when you say latitude, that's the ones you're talking about. The other ones are longitude. These are lines that would go from close enough to the North Pole all the way to the South Pole. And the beginning of these latitude lines is the prime meridian. And this prime meridian goes right through England, if you can get an idea through that. And everything starts moving from those directions, east and west of those, all the way up to 180 degrees. So you can give an idea. So now you can understand. So latitude going up and down, longitude left and right, which is east and west of 180. So I'll give you an idea. So like in Wisconsin or so forth, we would have a latitude line. I think we're probably in the 50, 60 degree, 50 degrees north, 51. And then longitude line would be probably in the 40 degree, not 40, maybe 61 degrees west. To give you an idea. Okay, let's go on a little further. Because how aerospace works, latitude, longitude, give you an idea here. And then here's the issue. The problem is that when we look at a compass in and of itself is pulled to a magnetic north, not exactly the true north. So on the maps, we need to take into account the variation or the deviation off of what really is true and what is magnetic. So I'm going to take a look at a map here for you, if you don't mind. I'm going to pull out your aeronautic testing supplement, and I would like you to turn to page or legend number 20, figure 20. And I think it actually corresponds to page 22 as well. Okay, it's a pretty big page. It looks like this. It's I think it's of Norfolk. If you can take a look and see. Can you see how? Okay, is everybody kind of on that page? Is everybody with me? If you're not with me, raise your hand, and we will slow down a little bit. Are you there? I see everybody's there. Okay. Now with that, I'm going to take a look at that particular one, and I'm going to ask you this question, this poll question. The poll question is referring to the FAA. This is the testing supplement CT 8082G, which is the book that we've got on Figure 20. So on Figure 20, it says, what is the magenta line labeled 11 degrees west? Now, let's have a little bit of a conversation here, if you don't mind. I'm gonna open up your mics, Dwight, and I'm gonna open up your mic, Josh, and my staff, Zach, you're here, so you're good. And Jason, if he wants to, I will let him join on. But basically, are you guys? By the way, are Josh and Dwight? Are you guys there in regards to this map? Dwight, you there?
Yep, I'm here, but I'm looking at figure 20 and it's hard to read and I'm not sure what the blue, there's a lot of blue lines. I'm not sure which one they're asking about.
Right, that's the beauty of this is it really is kind of confusing to a lot of people, lay people about this particular map. So if you look at that map, and it really is kind of difficult. If you look right in the middle, it says the word. It says the word Virginia Beach on it, right in the middle. Now,
Yep, I see Virginia Beach.
just right to the left of it is a dotted magenta line that goes from the top of the page to the very bottom of the page at a right degree angle, and it says 11 degrees west on it.
Oh, I see that.
Okay, that's the one we're talking about. So the question would be what is the magenta line labeled 11 degrees? And this is exactly what is going to be on the test. I mean, it's crazy because it's this exact question. So what does that line say? Now, we do know that a dotted magenta line is for Class E airspace, as we looked at earlier, but that usually is in a circle around an airport. This one is a magenta line. So what we just studied, we studied the aspects of magnetic true north versus magnetic north, and I'm kind of telling you the answer, but the poll question should really be is that well, I shouldn't do that. I'll let you guys enter the poll. Why don't you guys answer the question here? What is the magenta line labeled 11 degrees west? I gave the answer. I shouldn't have done that. Okay, both of you guys voted in, and you're right. You did choose the correct one, which was share the results. Magnetic deviation. Oh, I got one of you got. Oh, it says 100% voted. Now I see it. So basically, poll results show that a magnetic deviation between true north and magnetic north is 11 degrees. Is the difference there? Now the longitude lines are, and if on this particular map, we can actually take a look at them. They actually on these maps are actually perpendicular and vertical. So just to know that longitude lines, they are kind of perpendicular and horizontal on this particular map.
They're black.
Yeah, so I'm going to hide the results here. But so just give you an idea in regards to this, that that magnetic deviation, if you look here, how these numbers work. So if you look over here, where it was, if you look at my cursor, this is the map we were looking at right here during Virginia Beach, right here. And it looks like a 10 degrees, so it's about 11 degrees of magnetic deviation off of where it would normally say true north versus magnetic north. So our compass would be off by 11 degrees. Okay? You good with that?
Okay.
And the only reason I knew this is because I knew it from my private pilot test. Nowhere did I see this in any study material from the FAA on the test, but there it is. So go from there.
Real quick, Steve, you might want to, when you use your mouse, you might want to make it a little bigger because it's hard to spot it.
That's a good point.
Anyways, just FYI.
Yeah, that sounds good. Would I've done it maybe like this? Would that be good? Can you see that?
The color's off, but actually that's a lot better. But if you used like black or a different color than that kind of tan color, it would have been great.
How's that?
There we go.
That's good.
So it shows that line is 11 degrees off. So right here, just about where we are in Minnesota, it's kind of interesting. We're almost right on the money in regards to our magnetic. So we're only just about 1 degree off of true north and magnetic north. So when we fly, we really don't mess with it very much. I think I only did max of maybe 2 or 3 degrees either way, depending on where I flew, based on our compass setting. But in some cases, you're 10, 20, 30 degrees off in Washington State. So give you an idea. Okay, that's definitely one of the questions that are on there. So I'll make sure we cover that, and we're good with that. Thank you. Okay. Let's get back to erase all drawings, get back to pointer again. Okay. And here, magnetic deviation and the variation that goes there from north magnetic North Pole and true north. So give you an idea. Okay, let's talk about towers and structures for just a second, because it's important for us to know they're always around us. And in the aviation world, any tower that's over, I think the tower arrangement is over 200 feet, needs to have a particular light on it. And if it's over, I don't know if it's, I turn it off to 200 feet, I think it actually has to have a light. And then over 400 feet, it has to have a strobe. So you can get an idea of what it is. Now see, this particular tower, if the tower happens to be, this one isn't, but let's just say it's 1,000 feet AGL. So, and some towers can go up to 2,000 feet. But for us, as we operate and so forth, I want to make sure you know that the new Part 107 rules will allow you to operate up to 400 feet above this tower. So if this is a 1,000-foot tower, we can operate at 1,400 feet above, or 1,000 feet AGL, 400 feet above this tower, and 400 feet, 400 feet, maybe you can't see my mouse a little better. Maybe I can show this arrow. So if I'm over here 400 feet onto this side over here, I can be 400 feet this direction, and I may be up to 1,000 feet off the ground here, and maybe go all the way up to 1,400 feet above and over around this particular tower. So to give you an idea, and you do not have to have a waiver to operate that. That's just comes in the Part 107 rules. Okay. Okay. Let's keep on moving. Sorry. Do we have? Will ask me to make sure. Do you have any questions or answers? Questions at this present time on the subject of magnetic deviation, tower and height, and what else we just learned?
You want to see?
Josh, do you have a question? Anybody?
No.
Okay, no problem. Hang in there. You're doing great. Okay, let's keep on moving on.
There we go.
What?
I'm trying to learn.
Okay, I'll mute you all again, and if I need you, I'll unmute you. How's that sound? Okay.
Oh, what do you mean? Your glove too.
Yeah, I didn't mean to. Sorry. Okay, weather sources, where they come from. There's all types of weather surface observations from people who basically can figure out what they can see the weather and they make a report. There's automated reports. There's forecasts, and there's also just meteorological information that come from all different sources that are out there. All these can affect the UAV. As you can well imagine, weather affects the aircraft, and we want to basically make sure we understand that, because there are going to be some questions in regards to how it handles flight based on pressure, density, wind, and whether you're in inclement weather and whether the temperature has a bearing on that. A METAR. This METAR is a aviation route weather report, and this is what is observed either at the surface or for individuals who are flying through it at different heights. They make these reports, and they call them in, and these METAR reports get issued based on each airport that's out there. They're issued on a regular basis unless if there is no significant weather changes, then they don't actually issue a lot of them. But and then they put out a special one if perchance there's something that you need to be immediately made aware of. These are very important. I think problem is that we as UAS operators, we look at it and we kind of say, hey, that's we can just see the weather. But I think it's important for us to go through the entire process to understand what is out there at the nearest airports and what VTOR reports have been given already. Did we already go through this already? I thought we went through this already yesterday. We did?
Yeah, that part.
But I'm everything I'm missing. Oh, I'll do it for Dwight's benefit. Dwight, in a METAR report, here's what we have: is we have the identification of the airport that's there, and it'll be K, and let's just say it's MSP, which is K MSP Minneapolis St. Paul, or KGGG, and that's this Gregg County Airport that's there. The 16 is the day. That's the day of the month that happens to be. There's nothing else that's going to tell you, but just the 16th. So it's the first one. And if it's the first, it'll say 01. That'll be the first day. Is that cursor seen well enough? Will, can you see that well enough, or should I get a different cursor?
Well, if there's any way to make it bigger, that would be the key.
There's your airport. There's your airport designation. This 2-digit number here, the 16, is your date that you're worried about, and then the next number here is it's in Zulu, and Zulu is your universal basically time off of from England. Everything goes off of that. But basically, as long as we understand the same number, 1753 Zulu is the time that this report is active, and it was generated by an automatic generated report. Now the first 3 digits of this next item happens to be the direction on a compass of the wind. So it comes at 140 degrees. So 140 degrees is what? Let me know. If 90 is east, 180 is south, what are we talking about? Anybody? Oh, I guess you know what? I muted everybody. Sorry about that. Okay, it's just me and you, Will. So it's that wind is coming from the. I'll give it to you, Will. How's that? It's coming from where?
It's going to be coming. Excuse me. It's going to be coming from the. What is it? 140.
Yes, sir.
Sorry about that.
Got it.
I had to pull my screen back up here. So 140. Are you asking for a cardinal direction?
Yeah. Yep. Just south southeast. So
yes.
coming from the southeast direction. So if the airport runway basically is a large compass, it says basically coming from this direction into the airport. So you get an idea of that particular one. So 180 is here, 90 is there. It's coming in that direction. So you know what? I got too much junk on here. Let me erase all that.
Just to let you know.
Yeah.
See, what I was trying to fix here is my server just crashed. So
oh no.
I'm trying to save it here.
Oh no. Okay. Well, I'll let you pay attention to that and so forth. I won't throw so many your way. Then we're looking at at 140 degrees is the compass that's coming in at 21 knots with gusts up to 26 knots. You see that? Okay. And then the visibility. This is the visibility that's there is 3/4 of a statute mile. So I'm going to unmute both Josh and Dwight here. Let me go back to that again. I'll unmute you guys. Bear with me. Unmute Dwight. Unmute Josh. So here's my question. Can I fly my drone in this airport based on this thing? Because the visibility is 3/4 of a statute mile. Now, what you may have not have known, and I'll kind of make this a little bit easier for you, is that the requirement for a UAS to operate is 3 statute miles visibility. So if the weather report says 3/4 of a mile, then would you be allowed to operate your drone?
No.
Correct. That's exactly right. You're right. And I'm going to read the rest of it in the METAR here. it basically says thunderstorms. So TS is a whole list of numbers and so forth that come with it. And I think I might have a list for it. Thunderstorms with heavy rain. Okay. And then BR, which is actually another word for mist. Mist. Mist is going to be, it's broken at 800 feet. So it lops off the last two zeros here. So it's mist, broken clouds at about 800 feet, overcast at 1,200 feet, and there are some clouds there, cumulonimbus. So that's cumulonimbus clouds, which is not so great. And then the first one is actually the temperature, and the second one is the dew point. So as we will learn, I just want to make sure I burn it into your head that whenever the temperature and the dew point are within 4 degrees, you're going to almost always get mist or clouds or fog or something like that when it happens like that. This next one here, it happens to be is the barometric pressure, and it starts out with A, and it'll say barometric pressure 29.7, and it doesn't say point, but that's what it is. 29.7 is, and why this is so important is because airplanes in themselves can tell how high they are off the ground based upon the pressure, and the pressure reading is adjusted. And because the barometric pressure changes constantly, you need to consistently update that, because you could be off 300, 400, 500 feet and not be able to know exactly where you are. And there's other remarks that are there. So that's a good one to know. Okay, here's kind of a little more of a pointed to it. This is the airport. Again, the date and the time in Zulu. This is the period of time. So basically, it's this one. It shows that it's valid from the 16th at 1200 Zulu to the 16th at 2100 Zulu. So it gives you a time frame, even though that's where it was given. So it gives you a time frame. Here is the direction of the wind, 280 degrees at 10 knots. And visibility, when it's 999, it's basically got the limited ability, so you can see as far as you can see until the curvature of the Earth, which typically is, they call it 10-mile visibility. Sometimes they do it more. This one has broken cloud cover at 1,800 feet. And if there's any change in there, tempo changes. So it's saying that on the 16th from 1,200 Zulu to 1,800 Zulu at 7, this is at 70,000, hold on, 70,000 feet. No, hold on. Visibility. That's what they're saying, basically. New visibility. I remember this correctly. I can't remember off the top of my head. I don't know about that one. Broken at 10,000 feet, becoming, and then it says becoming, the wind is going to start kicking up from 340 degrees. It's going to kick up at 8 knots during this time frame. Okay? Let's,
A quick question.
yeah.
Are we going to get these slides, or do I need to write down these charts and everything?
Dwight, I'm giving you everything. You're going to get everything that's there. You're going to get a recording of this. It's going to be for you to have and to hold forever, as well as the Learning Center access too. So,
Okay. And these weather charts, how would a person get a hold of these? Are they free online or something, or how would you get these weather reports?
you actually, I will show you a little later where you actually go to get these, but you log into your pilot. There's a pilot portal to be able to look at all these weather reports for each particular one. So they're all online.
Okay.
I'll show you that a little later. Okay. Well, I think I muted you. Now you're back online again here.
Okay.
Do other customers get all the information?
Other customers or other?
Yeah, like the people that are.
Yeah, I'm going to provide the information for them so they can test it. It's all on my Learning Center right now. All this stuff is there, but more stuff too. So here's another example. Right off of the test, it'll say, so there's a report from Chicago, and the question they'll say is that, based on this META report, can I fly my drone? And Chicago is identified as Midway, KMDW. So I'll ask both you and Josh, can you fly your drone around Chicago with this wind report as if it were today? What do you think?
So it's the second one from the bottom. Is that I'm looking at?
Yep, I'll help you with it. It basically, here it is. This is a special report for Midway, KMDW.
Right.
Again, this is the 12 is the date, and here's the time, 1856 Zulu. And the wind is coming from the 320 degrees at 5 knots. Now the next portion from here over is what?
The wind,
Oops, I'm sorry, visibility.
visibility.
So, and here's the beauty of it. If
Well, half a mile is not a good enough.
if it's a little confusing, you can always look at another one. You know, JFK Airport, same thing, 180 degrees, 4 knots. Look here, it's half mile, statute mile with fog. Okay, this one's 1.5 statute miles with rain. This one has 6 statute miles with broken and scattered clouds. This one has 30 statute miles visibility scattered at 15,000 feet. This one has 15 miles of visibility, statute miles. So if you only have 1.5 mile of statute miles of visibility, can you fly your drone?
No, the bottom two we can't fly at.
Exactly right. Good job. On the top 3, we can. It's 15, 30, 6, all because we need at least minimum 3 statute miles of visibility before we can actually fly our drone. Very good. Excellent. Okay. Scanning techniques. This is important. We did talk about this a little bit. We kind of wrote over this really quickly, but it's important for you to use a special technique when looking at the sky. Instead of just looking up there looking for planes or helicopters, you kind of look around, oh, I don't see anything. Well, over time, we've learned that the best way for us to scan and to pick up items in the sky, because our mind does funny tricks for us, is to scan effectively by looking from right to left, but looking at about 30 degrees of the airspace at a time, and then slowly moving over. So, you look at it for about 2 to 3 seconds, and then you move over and you look for another 2 to 3 seconds, maybe another 10 or 15 degrees, and you overlap a little bit on your 30 degrees, and you look again, 2 to 3 seconds, 2 to 3 seconds, 2 to 3 seconds, 2 to 3 seconds, and you overlap a little bit. This is the most effective way to see moving objects in the sky if you're looking for planes, helicopters, other items that could be in there. So that sounds good. Will, you got any comments on that? I think we're good with that.
No, I think you did a very good job.
Excellent. Okay, atmospheric stability and talking about weather. The atmosphere is either in 2 different states. It's either in stable or unstable air. And so we have to figure out exactly which ones are depicted and which ones are affected by the atmospheric or meteorological conditions. And so I kind of want to make sure that we understand what's involved there. It could be movements of the air, temperature that happens to that, different turbulences because of severe weather, clouds, and so forth. For us in UAVs, it'll be pretty easy. We'll be able to quickly determine, for the most part, as long as the weather doesn't change so quickly, whether we can fly or not, but just by looking outside. But that is not always the case with airplanes when you're covering a great amount of territory. So as I said, instability versus instability. And we talked about this heat from below and cooling from below will affect these two. And I will tell you this, the one thing there will be, I'm going to go back to, there will be questions on the test. And for sure, when they talk about stable and unstable air, every time you inject heat into it, it will become unstable. And so with that, so I don't have to read everything that's here, but stable air typically means stratiform type clouds that are lower level, kind of hanging out there when you have fog, when you have like gentle rain, smooth air, and even when you can't see. Doesn't mean that it's bad because, oh no, you can't see out there. That also means that the air is stable. You could fly. There's not going to be a lot of movement in there that's in there, even though it may be raining. Unstable air is you've got these cumulonimbus or cumuloforming clouds, the big towering clouds. If you have heavy duty precipitation or rough air turbulence, then in of itself could sometimes be a sign of unstable air. Or if you've got good visibility overlooking a desert, you're looking at it, the heat is coming off of there. You can see for miles, but that doesn't mean that it's going to be a smooth ride. So air inversion or temperature inversions that go on are affected in many different ways. Let's say cool air coming off of the ocean onto the land. Usually you'll always see in the evening or cool evening clouds that are formed, again, by temperature meeting 4 degrees with the with temperature and dew point. Same thing for air coming off of a mountain, off the top of a mountain and coming down and forming clouds along the base of a mountain because of the temperature inversion. And if you look at this particular one, you happen to have what they call a squall line, or a form of clouds that form a wall as the temperature, as stable air is under unstable air, which basically means there's usually been a hot day, and the next thing you know, you got a cool front coming in, but right at the edge of that cool front is some definitely heavy-duty moving air that comes along there. And I kind of explained it. When warm air comes over the cold surface, and it goes through the night, creates when the forces create an inversion where air is lifted and forced up and over the other temperatured air. Okay, let's kind of move through this a little bit further, and I kind of already mentioned this. Air is formed when these two things are there. You know what? It's important to understand that you guys get into your plane and you're about ready to fly, and it's wintertime and they de-ice the wings. Well, there's a reason for them de-icing the wings, is so that the ice will not form on the wing and attach to the wing and change the property of the wing in such a way so it now there's more effort that's required to fly. And as that ice continues to accumulate on top of the wing front, as a picture is here, it has a different type of a trajectory, and it causes the plane to need more thrust and more lift to be able to flow through the air. So this is important to understand. The frost disrupts the flow of the wing, and this actually, Jason was able to get a copy of this particular UAS wing, and this is what happens on little drones. So to let you know that once it starts adding up and that weight is on there, it could definitely affect your UAS. So what happens? What's the cause in regards to structural icing that could affect? As the temperature and the moisture strikes the aircraft, it does does affect things. Let's replace this with our little drone as it's going through the air. What does it do? We're basically our thrust that the propellers that are moving either upward or lowered have less effectiveness. The lift then lessens. The weight, because now we have ice and icing on the blades are there, and even though the drag, we're not going one direction or we're going up, the drag in whatever direction, opposite direction the drone is going, is increased. So our weight and our drag ends up being significant on the UAS. So I think it's real important there. So I did not have any specific questions. Did you have any on structural icing? You did? Do you know what the question might have been, or off the top of your head? Okay, more of a definition. So make sure you do understand that structural icing is a very large thing. It's one of the 535 questions you can definitely be asked. Okay, taking a look at clouds here. How am I doing on slide numbers? Yeah, we're doing good. So the different type of clouds that are out there, that basically the cirrus, or your light, fluffy, feather-like clouds that are out there. And then we've got your medium clouds that are in there, your altos, and then you have your stratus, low level. These are the ones that you kind of, hey, that looks like an elephant. Hey, that looks like a pig. These are your that fall in that little area that are there. And then this is the ones that we have to be very careful of, the cumulonimbus. These are the big one, and I remember it because it's kind of like a bus. Cumulonimbus. Again, it's the most dangerous that there is, and it is one you definitely need to stay away from. So, Inside this cumulonimbus, it is amazing how the air currents are going, what's happening inside of those things. And if you look even at the top of this thing, it has like a tower top to it, so forth. The movement that's going on in here, and I'll change to my next slide here, that's going. It is truly amazing of what's happening as these things start to mature, how much wind is moving up and down. Sometimes these winds could be 60, 40, 50, 60 miles an hour. We've heard of Cessna airplanes flying into this and totally turning upside down and not even really knowing it, other than just the winds have just tossed them around because you feel like you're going up, but in reality you're going down. So it could be really um, um, impressive to watch, but need to make sure you stay clear of these cumulonimbus, especially with your UAV. Weather fronts, like we talked about, a squall line. It is amazing how those things pour in there, and that is one of the questions that I've had on the test before. Is that a line of cumulonimbus clouds where a temperature inversion happens is called a what? And it's a squall line. So it usually happens right along this particular front where your temperature changes and your cool air is coming up underneath warm air that's been there through a hot, humid day, usually in the afternoon when these come through, and you create these huge cumulonimbus clouds. And usually there's high winds that come along with that too as well. Like we talked about before, we talked about, let's talk about mountain flying for just a little bit too as well. As drones are flying, so it's an interesting thing is where if you fly near a mountain, here in Minnesota, we're nice flat territory, but those individuals that are out in the mountainous areas, this is one thing that's extremely important to realize. Wind flow, as how it goes over a particular obstacle is important for us to handle because it just doesn't flow in nice linear lines. The wind, as it comes over, creates a kind of a what kind of effect does it create? It creates a
Vortex.
yeah, vertices. Thank you very much. A vertice effect, and these things have extreme amount of power. As you're flying here, it'd be great because you're flying your plane or your drone up along the mountain, and the wind is lifting it up and pulling it upward. It's nice and floats up there. And typically, this is where you may see a lot of your gliders and set up. They get pulled up here and they play on this area over here. But if the glider gets on this side, or if any of your drones are operating on this side of the mountain, the wind is in such a turbulent fashion that you may not know exactly what's going on. The plane feels like you're at full throttle, but you're still heading right to the ground because the wind in of itself can no longer cause the lift underneath the wings. So it's important for you to understand this effect that's there. So, Will, you want to say something, please?
No. I was just looking for a word for you.
Oh, thanks. I appreciate it.
Effect is perfect.
And the interesting thing is, as it flows over a particular mountain or an object, and it may not just be a mountain. It could be a large building. It could be a hill. It could be a valley. It could be even a large item of some sort that causes this turbulent flow. So it's important to see. And as you can see, this airflow goes. It's amazing. This is actually a real picture. I think it might be either Mount Hood or Mount Fuji. This is really beautiful how it shows how this how the wind flows in linear lines across there, lenticular lines. Okay. Dealing with us as a drone, there are two important things you have to remember. How far you can fly from a cloud and how far you need to be underneath a particular cloud. And that's called your ceiling. And then for us as UAS operators, the rules happen to be you need to be 2,000 feet from horizontal from a cloud. And, oh, this is wrong. I'm sorry, it's 500 feet below cloud. Is that correct? Yeah, we need to change the slide. Sorry about that. Bummer. So it is 2,000 feet vertically and 500 feet below a cloud, and go from there. And you need to make sure, in our particular case, we have to have 3 miles of visibility. So we'll work on that, and it will be on the test. 2,000 feet horizontal to a cloud, or 500 feet below a cloud. So sorry about that. We'll get that changed. You making a note for that? Okay, our terminal aerodrome forecast. This is basically telling you what's regarding what the future will be in regards to a report. This is important to know because you know what the traffic or what the weather is going to be in the future. So TAF and your METARs are important to know, and we'll go right through it. So if you take a look at this particular one, again, this particular tells you the airport, PDX. And this particular KPDX, again, same way as before. This is the date, the 20th, and here's your time in Zulu, 1741. Let me see if you guys can see my cursor better. I'll go back to the highlighter again. So, so again, here's your date, and here's your time in Zulu. And then here's what's interesting. This is where it's good from. It's good from on the 20th at 1800 Zulu to the 21st at 1800 Zulu. So basically a 24-hour period that's here. So now we take a look at VBR. You don't really know that, but just kind of you can get a guess. It's a variable winds at 3 knots is what that is. There will be, I got an item that'll show you what those numbers are if you want to memorize them. So your visibility, again, 6 statute miles of visibility. And then here's your cloud cover. It'll take a look at, looks like scattered at 4,500 and broken at 6,000 feet. And so now here's what happens. Your future of your forecast. What is it becoming? So it basically says, so on the 20th at 1900 Zulu, looks like the wind will be coming at about 1,300 degrees at 8 knots, 6 miles visibility, broken at 20,000. And the same thing here, 2100, or the date is the date, and about 200. So the next morning at 200 Zulu, winds will change 11 knots at 100 degrees. So it's about east. Again, same thing, 6 miles, some rain, overcast. And this is the next little further into the day. The 20th of the day, 1,300 hours, and this is what's changing, 14 knots. So get an idea, that's the TAF. Yeah. You just need to know how to read that, just understand it. Airport, date, Zulu time, and then where it covers, and then again, visibility, I'm sorry, not wind, visibility, cloud. And then this is a future one for what's happening down the road. So hopefully that's good. Any questions on TAFs, METARs, a little bit of the weather?
No.
Yeah, you want to break it?
Okay. You know what? We're gonna take a 10-minute break, and we'll come back at 8:05, and we will then pick it up from there. Is everybody good for that?
Thank you very much.
Jason. Unmute Jason.
Unmute Jason.
Yes, sir.
Yeah, I don't know why I muted. I should probably keep.
Now I'm free.
He's free. Now I need to mute him. That's what I need to do. No, okay, so we're all good, everyone. Hey, Jake's on board. Hey, Jake, I'm going to unmute you. Can you hear us?
My homies.
Hey, how's it going?
Oh, I see how it is. You'll unmute Jake, but Jason, you're muted.
Yeah, hey, Joy's here right now.
Can they say
Hey,
hi,
Joy.
No, we're guests right now, so we can't have
Hi.
Hey, sweetheart, how are we doing?
Good.
Excellent.
I'm working at the American Dental Convention.
Excellent.
Yeah, now we're gonna go eat pie.
I like it. Hey, before you go eat pie, I'm going to give you one quick quiz. Hey, Joy, I'm going to give you a quiz. Here it is. So
You got to.
I'm going to launch a poll for you. Airports are control towers are what color? Select one of the following. A, blue, B, magenta, or C, yellow.
Want to answer? Take a guess.
Blue.
You got to push the button.
Was that right?
Oh, I don't know. 67% have voted, so I think I need one more person voting. I need Josh.
You told people
Jake,
to
and
take a
Dwight.
break. You told people to
We voted.
You voted? Anybody else there? Everybody took a break? Maybe they're at the bathroom. Okay, I'm going to close the poll.
Do you
And I'm
want
going
to
to share the results. So, 50% of you voted blue, 50% of you voted magenta. And the answer is, Jake, you know?
It should be blue, right?
It is blue. That is correct. Very good. Excellent. Okay. Well, here's what I'm going to do. I am going to give everybody a little 10-minute break. So at 5 after, and my time right now says,
2 minutes, Jake.
yeah, she got about 7 minutes. So, Jake, you guys still going to stick with us for a little bit afterwards?
Oh yeah, absolutely. We'll stay through the whole thing. So
Okay, we'll just take a little break for everybody. I'm gonna mute everybody, and we'll go from there. Thank you.
yep.
Sounds good.
Okay, is everybody back? I guess I got to open up the microphone so I can hear everybody. Let me get back to this. Okay. I'll unmute anybody who wants to be unmuted, and we can start talking.
I'm still. Oh, never mind.
I'm still. Oh, yeah, there we go. Okay, I unmuted everybody, so if they want to talk, they can, or they can turn their own mic on, mute themselves if they'd like. Let's start jumping into here to the loading and performance based. There are a lot of pictures in here that'll be about the about aircraft, but it will apply directly to a UAV. Hey, before I get started, just as a little for being back and being on time, I'll tell you a little story. There was a Texas billionaire, and he had his wife or had a daughter who was about marrying age. So he had a coming out party for his daughter. So he invited all the eligible bachelors in that part of South Texas to come on out to his backyard. In his backyard, he had an Olympic-sized swimming pool. And in the Olympic-sized swimming pool, he had filled alligators, crocodiles, and all kinds of poisonous snakes, water moccasins, and so forth. So he got all the gentlemen at one end of the pool, and he says, "Men," he said, "young men, my daughter is about marrying age, and so I have got a challenge for you. If any one of you men would like to swim from one end of the pool to the other end of the pool, I will give you either my daughter's hand in marriage, or you can have half of all my estate." And so as soon as he said that, all of a sudden, from one end of the pool, splash! One guy jumped into the pool and then just water flying everywhere. He's just swimming as fast as he possibly can. The father runs around the other side of the pool, comes over there and pulls the guy out of the pool, and he goes, "My, that's the most amazing thing I've ever seen." He said, "Young man," and the guy's trying to catch his breath. And he goes, "Young man," he said, "would you like to have half of all of my estate?" And the guy says, "No, sir." And he goes, "Well, then you want my daughter's hand in marriage. And again, everything that I have will eventually be yours." And the guy says, "Well, no, sir." And the father was looking really perturbed at him, and he goes, "Well, young man, what do you want?" And the young man said, "I want to know the name of that guy who pushed me in."
I like it. That's good.
So the issue sometimes is to get to the other side, to get to where you want, sometimes it requires a push.
I like it.
Yeah, okay. So part of it, what we're going to talk about is your drone or your plane being pushed through the air. There are factors that are involved in regards to what's involved with a drone. And it's considered the weight of the drone, the stability of the drone and the items that are in it, the loading factors that go onto it, and the weight and balance of that particular drone is extremely important to aeronautic and air flowing through the air and making sure that the drone in of itself stays afloat. And determining these factors, there's other things: temperature on density and humidity on density, or moisture, and so forth. And then, I'm sorry, I jumped past that real quick. And then we're talking about maintenance pre-flight procedures, which are extremely important, and the operation manual that you need to keep with you at all times. Now, the interesting thing about this, even though this is a jetliner we're looking at, the concepts are the same in regards to where center of gravity is in your particular drone and where the center of lift happens to be. So if it's offset, you have some other factors that could be affecting this, which then would cause the balance. So as we look at this, adverse balance conditions can affect the flight characteristics based on where weight happens to be. My brother served many of his years in the Air Force. He was a load master. So everything that came onto a plane, he told exactly where it's supposed to go by calculating the weight and where it was based on the center of gravity of that particular aircraft. So PICs need to make sure you understand the center of gravity of your equipment, because loading a particular camera or another device or infrared camera on your drone could affect the center of gravity significantly, thereby causing it to fly incorrectly. And it will affect your climb and your balance. I will assure you, at least I had 2 questions on the knowledge test from this particular chart. If you go to chart, oh, where's the number of this? Jason Christensen didn't have the number of that. Okay, if you look in your aeronautic knowledge supplement, there, keep this in mind because this is going to be needed. This load factor chart, you don't have to memorize it. It will be given to you in your open book test, and it's on figure number. Can anybody find it for me? The load factor chart. Here it is. Got it. Figure number 2, right here.
It's figure number 2.
Thanks. Figure number 2. I knew that. I'll write that in. Okay, if you look at that particular chart, the one on the screen, same thing, but it's in the. It'll be given to you. So here's going to be. Actually, with me here 1 second. I apologize. On this particular chart, there will be a question in regards to your. So we'll come back to this. Let me just show you the graphic picture of this, which is great. So think of this as a drone instead of a plane. But as your plane takes a bank and it starts to bank the angle of, as what's going on with your angle and the angle of attack of your particular wings, the effect of gravity on that particular device really is significant. So as you go into a bank or turn into a bank, the amount of weight now your drone weighs, it has to be taken into account. So now your drone, if you look at this, your drone flying level based upon the air that's going over the wings and the propeller and all that kind of stuff, you're looking at a 1-to-1 ratio in that how much weight that happens to be. So as you turn a 20-degree bank, the weight now is 1.06, not much at all. But the end result is the amount of thrust that's being pushed away from you and causing extra weight or for how much the effective load of the particular airplane is 1.31. Now, if that airplane takes a 60-degree bank angle, guess what? This plane now weighs twice as much as it does. So all the other factors that go into handling the force of this plane have to be taken into consideration. So either you need to add more thrust, add more lift, all kinds of things that are going in there. And if you're taking an 80-degree bank, that plane weighs 5.6 times what it is. So let's go back to the graph. It'll show you right here. Here it is. So I happen to have 2 questions on my Part 107 test. The first one was, if I had a bank angle of 30, what does my plane, how much does my drone weigh? I have a 10-pound drone. The answers are A, 10 pounds, B, 11.54 pounds, or C, it weighs 20 pounds. The correct answer was B. At a 30-degree bank angle, the load factor on how much my plane weighed in G-factor units ended up being that my 10-pound drone now weighed, so if I go down the chart, so my bank angle was at 30 degrees, so my 10-pound drone multiplied by 1.154, now my 10-pound drone weighed 11.54 pounds. So the answer was B. The second question I had on my UAV course was, my bank angle is 60 degrees. How much does my 23-pound drone weigh? So 23 pounds at 60 degrees is times what? So 23 times 2 is 46. So the load factor, my drone was weighing 46 pounds. Everybody get that? So those 2 questions will be on the test, and this little load factor chart, you don't have to memorize it, you don't have to know it, you just have to know that it's in figure 2 in this particular book, and once you can compare 30 degrees, 1.1, 60 degrees, 2.0, you've already got 2 of your 42 questions you got to get right. Bada boom, bada bang. Huh? Love it. Okay, let's keep on going here.
I like
You like that?
to incorporate more bada booms.
It's a no-brainer for you guys. So let's just read through this. Load factors are important because it affects two areas. It's possible for the pilot to impose a dangerous overload in the aircraft by doing wild and crazy maneuvers. And also the increase in load factor increases the stalling speed and makes stalling possible and a seemingly safe flight speeds. So you could be going very slow, but the issue happens to be is that if you created this bank angle, the plane will actually, or your drone, will come crashing to the ground. So I think many of you flying UAVs for a while have kind of experienced that as you're kind of doing circles or doing different types of patterns where the drone actually, you can make it stop in midair, but if you don't do something with it, it'll just fall right to the ground. Okay, it affects two areas, maneuverability and controllability. Maneuverability, allowing you to be able to move the drone in different areas, basically with the idea we're allowing the drone in itself to be able to handle the stress of the operation and the maneuvers. And it's also governed by so many things. How fast it is, how heavy it is, the inertia that it carries, the size and weight and all that kind of stuff, and how powerful the motors as well as the particular propellers or blades happen to be. So this is your maneuverability. Where can it go? Upwards, leftwards, upward, down, and so forth. The other controllability is then the flexibility of your operator control to be able to operate in a particular path and fly a particular attitude. So controllability versus maneuverability, two important things to learn. So did you have a question on those? Controllability versus maneuverability? Don't know.
Yes.
Yes, you did.
Actually, I have one.
Jake, did you have any questions in regards to those two on maneuverability and controllability on your test? Do you know?
No, I didn't have any questions on those two. I just had a few, like you were saying, on the calculations of the load of the aircraft on a bank turn.
Okay.
But I never saw any on maneuverability or controllability.
Mine was it had to do with center of gravity.
Okay, center of gravity is the next question, so that might be what it is. Center of gravity, what it does, what effect it has on a particular drone. And as a drone, the center of gravity, where it happens to be. I do know when I had my 172, if I put more equipment up in the front, or if I happen to store a lot of things like my golf bag and I had two people in the passengers in there, it became tail heavy and I had to adjust accordingly. So I adjust my ailerons accordingly. But it's important for you to understand center of gravity is very important for us to be able to understand the stability of maintaining a stable and a level flight. And it will affect a lot of things that go in there. So just give you an idea on that. See that nice graphic? Can you guys see that? Heavy and then balanced and nose heavy. Yeah. That's some high-tech graphic there. So, and if you don't load your plane correctly, what ends up happening is that you get one of these situations where it gets loaded and the tail or the nose comes off the ground. So that's a bad deal. That's a bad day. Okay.
Well, you could another application is, you're talking about fixed wing the majority of the time, but even on a quad rotor, you're going to create more work for each of the other motors if it's trying to compensate. The gyro is fighting itself when the weight's not distributed evenly.
Very good. You guys hear that from Zach? If sometimes you'll hear the different motors or gyros going in such a way that they'll have different speeds while they're operating. It's trying to take into effect a center of gravity that might be off, and so you might hear those motors going a little different way. And many times you hear that going because of weather. Wind is blowing it. If you have a crosswind or a lot of knots, to try to stay in the same position, it's adjusting accordingly for that. So that I think we can hear that visually sometimes. You know what? Here's some important things. These are all very important, and I want to make sure you at least know them in the back of your mind. Things that can affect, I'll say, excessive weight that reduces the flight performance in almost every aspect, including, so if your drone is weighing down or you have too many things on it. Some of our customers have huge, large cameras. We have one of our customer that has 2 cameras on their drone. It's XM2. It's impressive. I should probably put a picture up here. But requires a higher takeoff speed and in some places a longer takeoff run. If you have a fixed wing aircraft that's not VTOL, vertical takeoff and landing, if it's a launched, it requires a longer launcher. And it ends up becoming a reduced rate of climb as it takes off and so forth. It can't take off immediately or it's vertical, it can't take off. It might have to take off at more of an incline or a lower incline. Again, lower maximum altitude, shorter range because you have so much weight. You have to calculate how long your battery will run, how much your battery will handle over that particular one. If you put too much weight, too many cameras on it, you're going to, if you don't have the ability to be able to fly out to your location and fly back, your battery will be used up by the time you get out there because of the excess weight. Reduced cruising speed. Again, we talked about maneuverability. And then definitely it'll stall at a higher at a higher stalling speed. And then again, landings just for regular drones, so regular airplanes, you have to land at a higher speed. I do know for me, I had a situation where I was flying into Rochester International Airport in my little Cessna, and behind me happened to be a 727, and so the guy asked me to speed up my 172, and I had that little airplane going as fast as I possibly could, and it was pretty funny because he made me land at full speed, full throttle, and it was a little scary for me, but I had to get it on the ground, and that would have been the same way if I would have had a very heavy loaded airplane. I would have to land it at a higher approach speed because it'd stall because the weight, you'd have a higher stalling speed like we talked about earlier. And it took me a while to get the thing to slow down so I could turn off to one of the little taxiways. Okay, let's look at some of these charts here a little bit further too as well. But it's hard to see this particular one because I want to get a little more in depth on the charts and go from there. As you can see, there's a lot of things that are happening here.
At the bottom of each of these.
Say it again.
There's a figure at the bottom of each of these.
Hey, there's a figure. Okay, let's do this. Let's take a look. Let's take a look at figure 25. So if you go to your Airman Knowledge Testing Supplement, which if you don't already, you can download it on your handout. It's the larger handout that's there. And look at, I think it's actually page 25 and figure 25. And we'll take a look at this chart a little bit better. And this is definitely one of the charts that's on the test. This happens to be the Dallas-Fort Worth sectional. And there was a couple questions that came out of this particular chart. Now, I'm going to point out a few things on this particular one so you can get an idea. Now, if you look, this happens to be blue solid lines that are around here. Now, we learned before that airports are identified in blue and magenta, and that the lines around them that identify what class of airspace are in blue, solid magenta, dotted blue, and dotted magenta. So in taking a look at this, solid blue indicates what airspace that is in. Does anybody know off the top of their head? You can raise your hand and I'll call on you. Or not. I'll tell you what the answer is, so we won't make everybody rush to fill it in there. A solid blue lines or circles around here means that this is the highest level of serviced airport that there is out there. And as you well know, Dallas-Fort Worth is very busy airport. At one time, Dallas-Fort Worth was one of the largest airports in the world. And this happens to be a Class B airspace, as in Bravo. And we looked at it because it's a dark blue, and I called it royal blue, even that's not the right color, but I'm going to call it royal because it's the king. It's the king of all airspaces, Class B. So as you look at this particular, and if you look at your particular sectional, kind of have to hold it this way. Might be a little bit better to easier to see than actually the map I've got. I wonder if I can zoom in a little better. Can I zoom in? Nope, won't let me do it. So if we take a look at, let's say we take a look at number 5. If you look at number 5, right to the right of it, it says 110 over SFC, which is over the surface. So this goes from the surface in that inner circle to the ground all the way up to 11,000 feet because we add 2 zeros to the end of that 1100 or the 110. So at 11,000 feet to surface, that is the Class B airspace. We can't touch it, can't be in it. If you look just a little bit to the left of number 5, right over here where it says 110 over 15, you look at this little carved out area right here, all the way around to this little blue area here. That little carved out area is 110 over 15 or 110 over 20, those two areas right there. And it talks about that. It says, look, you can go, the top is going to be 11,500 feet. The lower is going to be 2,000 feet. So since our drone can only go 300 feet AGL, now this is MSL, but still, we can know for certain that we'll be able to operate our drone underneath that particular area. And underneath that area would be considered Class G airspace, which you can fly. So it's mind-boggling to realize you can actually fly that close to the airport that's there. Now, if you look closely where it says 110 over 15, that points to this little teeny area right in there. It's like a little teeny kind of a triangle area. So just to give you an idea, you still can fly all the way into that area. So other than this area right here, as I follow my area around this particular inner ring, and it goes in here, and if I look correctly, there's another area that's 20, so I can go there, come back around to here, and it looks like this might even jettison out to the right. So I might have a problem here. I might have to go all the way out here to surface. See what's the surface? Out to the outer blue line, goes down here and over here. So that would be the area I would not be allowed to fly under my present Part 107 unless I have a Part 107 waiver, a Dot 41 to operate in certain airspace, which would be right there. So you can fly underneath this ring, which is 3,000 feet. You can fly under, let's find another one. This ring is 5,000, so as it goes out, these rings are like an upside down wedding cake. So the middle piece goes right to the surface, and then the lower level of this is depicted. So if you look here, the top level is 11,000 feet, the bottom level is 3,000 feet. So you can fly underneath this entire area with the exception of these little dotted blue lines that are out here on these little airports. Dotted blue lines, remember we said solid blue is B, King. Solid magenta is C, as in Charlie. Dotted blue is D, as in Delta. And dotted magenta is E, as in Echo. So in this particular case, we have we have B, C, D. So we have dotted D airspace that's out here. And in that particular airport, right there, I'm here. See who that is. It's called Fort Worth Alliance is the name of that airport, AFW. And minus 30.
Just a quick question.
Yeah.
Why do they carve out those little areas that you can fly under? You know, so you were talking about that little area. Why would somebody arbitrarily chop out a little chunk of the Class B airspace?
It has to do with the progression of so you have departures and arrivals at all these smaller airports, but they have to have clearance enough for the arrivals and departures into the main airport, which is Dallas-Fort Worth. But you still have to allow the capability of these other aircraft to enter and depart that airspace to land at these other smaller airports.
Like, for example, this particular airport here, it might have a pattern where you come down this direction, and then you turn base, and then you come back through to land at that particular airport. It gives you space to be able to operate in that particular airport without having to be in Class B airspace at all, because this area out here is what we're at 3,000 feet. So you can come in at 2,000 feet, fly in, land, and land at that particular airport and not be in Class B. Class B airspace is extremely controlled, very mandated. Everybody knows what you're doing at all times in that space. You're not allowed to enter that space. And a lot of airplanes do not have, believe it or not, do not have air transponders, and maybe don't even have a radio. So you're not allowed to be in controlled airspace like B unless you have those items. So a lot of airplanes will maybe fly out a little smaller airports out of here, just like here and here and here, where they are not required to enter into that airspace. So,
Gotcha.
and it could be locations, it could be the city, maybe it could be the skyline, all kinds of issues that are there. This one's a little more complicated than most. Most of them are just sequential circles that are there. If I remember the question, I don't know if anybody can remember off the question. I believe the question on this particular one had to do with a location at the north of Dallas. You guys remember this? I can't remember off the top of my head. That's why I need Luke to go and remember this. So as we look at these items, we can get an idea. So the question would be: is around number 1? So would we be able to fly our drone if we were right around number 1? We look at it. The first thing we look at is, again, B airspace. If that's the case, then we look at what area of the inside that circle we're in. So it goes to 10,000 feet top, 4,000 feet at the bottom. The only way we have to worry about is this little guy right here, and that goes up to 2,500 feet. So as long as we're not flying inside this little blue airport here called Denton, we're going to be okay. Denton DLT. So technically, we could actually fly there. So I'll give you an idea. A lot of things going on here on this map. So the question would be: is that if you well, we'll move on. I think it's a good one, good chart to move on. Let's go on to the next one. Okay, let's look at chart number 24. Let's turn to chart 24 right across the page from you. Okay. And I'm going to ask you, does anybody know what the control tower frequency is for Majors Airport, labeled GVT? And
You said Majors Airport?
Majors Airport. Yep, and I'm going to give you an idea. It's right in this area right here. So what would be the frequency of the tower of that particular airport?
Are you asking people to raise their hand?
Talk out loud. Unmute themselves and talk if they wanted to. What is the control tower frequency? And it would be right in this area right here.
Yeah, I can't quite make it out.
Can't quite make it out?
Can't quite make it out.
Can you zoom in enough? Actually, you know what I should do? I should actually pull up a different map that's so much better than this. I should pull the raw data. What town are we in? Is this Illinois?
You can actually share your browser and show people how to get to their sectionals and look up. So everybody go to your nearest, go to your sectional chart near you. And I want you to look up your house and then figure out what the closest airport is and what you know,
Well, let's do this. I'm going to go to Minneapolis, St. Paul, and hopefully this will be a little clearer view for you guys. Okay, is this clear if I zoom in a little better?
yeah, that's a little better. Yeah.
Okay, and graphic-wise, this should be good. So let's take a look at Flying Cloud Airport. Oh, you know what? Let's look at the sequential signals, circles here. This is a very pretty one. So inside Minneapolis, St. Paul, we've got the inner circle for the airport. And if you look closely, we look at it, it says 10,000, which is 100, 10,000 plus the 2 zeros, 10,000 over the surface that are there. So in that particular ring, we are not allowed to operate unless we have a waiver. But we go to the next ring that's out here, and the next ring, the lower level of this ring, is 2,300 feet. So we can operate. Look at this. I had one of my clients call me and said that they got a job to film the brand new stadium, the new U.S. Bank Stadium, where the Vikings play. And he asked me if he was in the right airspace. And sure enough, look at there. He fits right in that little area, so he can actually fly the U.S. Bank Stadium where the Vikings are going to win this Sunday. So exciting. So to give you an idea, so all these areas underneath this are G is in Gulf airspace, which is perfect for us UAV, except for when it has the dotted blue line. Dotted blue line. So your solid, again, is B is in Bravo. It's important we just learned this one right off the bat. B is in Bravo, magenta is C, and dotted B, or dotted blue, is D. So this is D airspace out here. So, and it's because the St. Paul downtown Ullman Airport is right there, and it's covered in that particular area. And here's our Flying Cloud Airport. So if you take a look at where we live, down 169, you turn, and right there, we are inside that airspace that is dotted in there as class. Again, B is blue, C is magenta, dotted blue is B, C, and D. D airspace, Delta airspace. You get an idea. So once you're outside this area, anything below that we can definitely operate in. This is the airport that I did all my flying out of, Air Lake in Lakeville, and it is in Class G airspace. This is not a dotted line. This circular here is a VOR. See, remember, this is a dotted line. A VOR is a omnidirectional radio that tells the different airplanes what direction they are off of that particular radio, that radio signal. So you can call into it and realize what you're on, and it'll tell you what direction you are. So you can get proximity with this one and that one, and you could create a little diagram. But because we're out here in this area, it's in Class G airspace, and as an operator, as a UAS operator, you can operate as close as you need to this airport, including up to and operating on top of the airport, as long as you're not operating in such a way to cause interference with manned aircraft. So important to know there. What are the things that I want to take a look? Let's take a look at something else in regards to towers that are important here. So let's take a look at this particular, let's take one that's kind of close in that would push us through. So one other thing to take a look at is this. This throws a lot of people off. This it's either like a magenta larger band, like a banner or a band. It comes in blue and magenta, and these are the two different types of airspaces. So if you look at your legend and on your section supplemental, it shows the two different bands that are on there. The magenta is E, and it's 700 feet, so it's the lower one, and the blue is at 1,200 feet. So what that's saying is that basically from the ground all the way up to 700 feet, if it's magenta, or to the ground to 1,200 feet, it's open space, and it's there's airspace that starts above that, and that would be considered E airspace. So for all practical purposes with UAV, we're not concerned about what is considered elevated Class E airspace. We're only concerned about E airspace when it's attached to a different airspace and goes to the surface. This is real important because I missed one of the questions basically on that, and I'm gonna pull up a map and show you one that will affect that. So I'll give you an idea. But just I want to make sure you understand that. Now let's take a look for at a tower. So if we look out here in YZ, and I'm going to take a look, zoom in right here, YZ, there are some very large buildings that are out there, and actually there's an antenna tower that's out there. It's by the prison that's out there. And this tower is 1,319 feet MSL, mean sea level, or it's 350 feet AGL, actual ground level. So it's 350 feet off the ground and above ground. I'm sorry. So 350 feet above the ground. Now, how high can you as a UAS operator fly above that? Now, normally without the tower, we would only be allowed to fly 400 feet AGL. But above this tower, you get 400 feet on top of the 350 feet AGL, means that we can actually fly 750 feet off the ground AGL, as long as we stay within 400 feet of that particular antenna, either above it or off to the side. So we've got that ability to be able to fly. So just to give you an idea. Okay, downtown tower, same way. Looks like the tallest tower there next to the stadium, and there's that's the baseball stadium. Here's the downtown towers are 889 feet. One of our previous companies have antennas on top of that tower, so you can go 889 feet plus 400 feet. So 1,289 feet above that particular location is just fine, and we're below the Class B airspace, so that will be just fine for operating right downtown Minneapolis, believe it or not, over the building. Now you can't operate over people, but you can operate over buildings. Okay. I think that'll be helpful for you. And I'm trying to think of what else things we could take a look at here that would be really important to see.
Is it your plan to have the mics unmuted, or do you plan to only allow them to talk at certain points in time? Because sometimes you do really well with kind of a
interactive.
Um,
Yeah, I hate for it to be all lecture all the time. I kind of want it to be interactive, but I don't want to
do that, and just warn people beforehand. Hey, if it just gets out of hand, I might mute people and then just have you submit questions. Just in the interest of time, we've got a lot of things to cover.
Yeah.
But if there's something that you didn't quite catch or need clarity on, just go ahead and do that.
I got a question.
Yeah, go ahead.
Before you switch to this new map, you were going to tell us about the radio frequency and how we would know that by reading the map.
Okay, take a look at this one. We'll zoom right in on this particular one. Let's say Anoka County, Blaine. I sold my airplane to the guys that operate there at Anoka County. I was going to ask you, what is the control tower frequency? So taking a look at this particular one, and you look at it and you go, oh, do I have to guess? The beauty of this, you actually go to the supplemental chart, our airman testing supplement, and you go to the legend, which is legend number one right here, this one right here, and you take a look at the little piece that talks about airport data, right there in the middle, airport data. And actually, I wonder if I should pull this up. And if you look right below the name of the airport, it'll say CT means control tower. One of the questions on my test was, what is the control tower of, I think it was Wichita, Kansas. What was the control tower frequency? In this particular case for Anoka County, it's 132.4. Okay? Give you an idea. And also, at times they'll ask you what the Unicom frequency is. Now, again, you got to go back to this particular, back to the legend, look at that chart. And if you notice at the bottom where it talks about, where it says, in this particular one, 912, that's the length of the runway. And L is lighted, and it says there's a 50 in there that says, I can't remember what the 50 said. 50 is the length of the longest runway in hundreds of feet, so it's 5,000 feet, which is actually a pretty long runway. And then it tells you the Unicom frequency. So one of the questions was Unicom, which is 122.95. So those are two questions I had about frequencies. Jake, are you still there? Did you have any questions in regards to about airport data that you could recall off the top of your head?
I knew I had a couple on just identifying what type of frequency you had, whether it be Unicom or something else. The CTAF one was on there, so it was just kind of they'd give you three options, and they'd all be three different frequencies that you see on the chart.
Yep, right.
Trying to confuse you, so you just have to be familiar with which one's which.
Right. So control tower 132. You're right. The question. You're right. All three of the questions I got, same thing, was all different frequencies. So they're just wondering whether you're going to guess or whether you really knew that was the control tower, whether you knew this was going to be weather, and whether you knew this was going to be Unicom for general frequency or general communications. Unicom. So yeah, that's important. That was good. You know why I've got you on here, Jake? I guess. Are there any questions that you could think of off the top of your head on these VFR charts that you have that you could remember?
I had one that was pretty difficult. It was like a multi-parter combining the VFR charts and the UAS rules. So one of them was refer to this sectional excerpt, and then look at this airport, and then about 8 nautical miles to the southeast of this airport is a obstruction with flashing lights.
Okay.
And so like I went to the chart, pulled it up, went to the airport, identified that, and then used the little ruler, the ruler tool that they give you to estimate distances.
Yeah.
I estimated like 8 nautical miles to the southwest or whatever it was, and there were like 5 different obstructions. And I had to refer back to that Legend 1 to figure out that the one with high intensity lights is actually different than a normal obstruction.
Okay.
And then, so then after that, the actual question was, how high above this obstruction can you fly? And I think we've talked about that a few times, that it's 400 feet above the very top level.
Yes, and you know what? I think it was Minot. Where's Minot, North Dakota? Is it Minot? Where's Minot? Devil's Lake UAV. Is it out here? Yeah, it's where it is. Right there it is. I think this is the one that we were talking about. In Minot, North Dakota, it had here was the location out here in the tower and so forth. Now, hold on, this is a little different because this one had lights on it. This down here is 1,000 feet. I thought it was one that was in this particular area, but you know what? Jake brings up a good point. Take a look at this. Okay, if you look at this band of magenta, that is that raised, elevated class E airspace. Okay, that goes, and that particular one goes like from 700 feet off the ground. But the interesting thing about this is that you have your class D is your blue, and your class E to the surface is this dotted red line. So here's your class airspace. So D and E. And here's another one, D and E. E is out here, this magenta out here, and not this. So to his question, so I got this one wrong. When it asked me, the tower to the right, so basically it's 393 feet. Can you fly here without calling ATC? And I did this wrong, so don't listen to that particular one. But it was 393 feet plus a 400 feet. That puts you at 4, 5, 6, 7. Puts you at 793 feet. oh, I said you're going to be into class E elevated, and you need to call ATC, but that's not the case. The only time you need to worry about ATC is if you're inside of class E to the surface. This is real important. I even confirmed this with the FAA. So you can fly 400 feet above this particular tower, which is 793 feet, almost 800 feet, and still not have to talk to air traffic control or have a special permission. You can fly that high. So it was important to understand that.
Explain to them where the Class D goes to the surface.
Okay, yeah, Class D is this blue dotted line, and it goes to the surface and up to 4,200 feet in that particular circle only, and in this particular circle only. Now, this particular one, this will go to the ground right here. This is the magenta one. This is Class E as an echo inside that particular area, and outside to this area is echo airspace. So those are the ones that are considered. But in this particular one, that particular tower right there, if we're looking at 393, you can fly above that particular tower 400 feet and be okay. Okay, does that make sense? A lot of things happening on these maps. It's truly amazing to realize what's going on. This is a blue airport, which means it's controlled. It has different surfaces, and you probably take a look at it. It might not be controlled all the time. But and here's the control tower frequency, 118.2, similar to the one that we just looked at. And then your Unicom, 122.95.
So I have a question for the attendees. To find out when the hours of operation of the tower are, where would you go to find that?
That's a good question. I actually don't know.
Is it the airport directory?
Very, very good.
Airport facility directory, right?
Who said that?
Jake did.
Yeah, that'd be me.
Very good.
Now, the interesting thing about this is you can also, there's some other things with these different types of little dealy bobbers around here that can tell you what kind of services are available, whether they have gas and all that kind of stuff. Like the little star at the top, what it means, and so forth. They so it gives you an idea of what's going on there. And then it has a rotating beacon. This little star means that it has a rotating beacon all night. So you can keep on looking for it. So I'll give you an idea. And just as we're looking at this, make sure you understand this particular thing really means nothing other than directional. It doesn't mean anything to do with airspace. This like compass item. This means that there's a VOR, and this VOR sends out a signal, but it doesn't mean anything to do with airspace. So I'll give you an idea. And these numbers here are terrain height, how high the ground is at this particular one is 2,800 feet, 3,000 feet as far as elevation. So I'll give you an idea.
Hey Steve, hold that right there. No, zoom back in to that to where you had it. Oh no, that's a little bit too much. Okay, right there. Hold that. Okay, so does everybody see the Minot Airport that Steve was talking about up there? Right there, yes. Now to the northwest, or actually northwest of that, is another airport. Why is there a difference in the depiction of those airports? So one of the controlled airports, the one to the north, is it just shows a runway. But yet the one to the south, down there by the city, by the larger city, it's an actual circle with, looks like 2 runways in there. Why is that different?
Good question.
It has to do with the length of the runways.
Yes.
This is a military runway, and the length for this runway, actually L13.2, is 13,200 feet. That sucker is massively long. It's almost 4 miles, almost 5 mile long runway. So it can land some unbelievable monster airplanes. And this little guy, the longest their runway is 7,700 feet versus 13,000. So right there's your L132, 13,200 feet. L77, the longest runway is 7,700 feet. So truly is amazing how monstrous this thing is.
So whenever you see just a runway out there, in a controlled airport, even in an uncontrolled, if it's just a runway, that means it's longer than 8,000 feet. Or actually, I don't remember, 8,000, almost 8,100 feet.
Mm-hmm. And you guys out here, the little R, that's a private airport, and they're usually a grass runway. These little guys right here. There. Okay. Okay, let's keep on moving on. How we doing? Oh man, we got. Let's get back to the slides.
I got a quick question.
Yeah, on this slide or any.
Yeah, well, we were just talking about those frequencies. You said there was 3 frequencies. I only heard 2: the control tower frequency and the Unicom frequency. What was the third one?
ATIS and ATIS called ATIS, and this is where you call in to get your weather.
So ATIS is a weather frequency?
Yep, I don't know if they're actually going to tell you that. ASOS, they get ATIS, and there's one different one that you call in and you listen to the frequency, and it'll say something like this. Information around Flying Cloud Airport, basically October 20th, 1700 Zulu to 1800 Zulu. It'll say winds at 180 knots at 3, with 3 gusts up to 7. Looks like 10 miles visibility, clouds at whatever. And it'll say this will be information. Oh no, it'll say available runway is 29 west. And it'll say basically report at 10 miles. Information. This will be information. Bravo. So and it'll just keeps repeating it. So you, okay, as a pilot, when you call in 10 miles away, you call them in and you say in this particular case, let's say Minot Airport. This is November 167 Bravo Charlie. I'm 10 miles out at 2,500 feet, and I have information Bravo. And it'll say, excellent, contact us at 3, continue on in. Yeah, that's basically it. So it's a frequency so you can listen to weather. So anybody can listen to that weather anywhere, as long as you can get it on your Navcom radio.
Okay.
You can get it from your house. Okay, but the questions on the test will be for, that I know of, as tower and Unicom for sure. So I think that'll be helpful. And then how high I can fly above a particular location, it'll say. Now there is one, let me go to one, let's go to Fort Wayne. Does anybody know what Fort Wayne is? Let's go to Indianapolis. Okay.
You don't know where Fort Wayne is?
I didn't know what the airport designation signal was. That's all. So, hey, there's Kokomo. Jason, there's your home territory. Okay. Let me get up to Fort Wayne here. South Bend. Here it is, Fort Wayne. So one of the questions on the test was, Jake, can you remember, was it Fort Wayne or Des Moines when they asked you a question on you had to follow a train track? Maybe it was Des Moines. Bear with me. I apologize. Let me go over.
Yeah, sorry, I'm not sure which one that one was.
I apologize if I'm making people dizzy with this, but I wanted to.
The refresh rate is pretty slow, Steve. So.
Oh, you're not seeing this? Move it. Okay.
Yeah.
Well, there was a question, and it was similar to this, in that you had to, let's say you you had a job to film the train from Central City all the way down to, and it had something like down here, like the train came out at, let's say, Iowa City, and it asked if you had to contact ATC. So you follow the little train from Center City all the way down through, and you realize this outer ring of, remember this is not blue, it's magenta, so it's not B, but it's C, so it's C airspace. And the outsider ring was 2,100 feet. but the railroad happened to go right through the middle of the town, so right to the surface. So it came out the backside. So the interesting thing is, if he was required to do an aerial photography of the train as it goes through, he would have to go right through the middle of Class C Charlie airspace because it's to the surface here. You see that 4,900 feet is the top and the surface to the ground. So he'd have to go through the airspace. So would he need to get permission from ATC? And the answer is absolutely. And that for sure is one of the questions on the test. I got to memorize more questions and then we'll be able to have these little better answers. So give you an idea. Okay, let's go back to my PowerPoint real quick and see how far we are. Okay, I'm going to go through these charts because we kind of.
That's so you can remember that same instance and the airport.
Yeah, I got to remember the radio communications. This is the interesting thing about this is it has been a big thing in the past, but now it's being changed. But there is situations where you have an emergency situation where you need to communicate tower. You need to basically know what frequency to communicate on if you need to communicate on those guys, and how to communicate with the NAVCOM radio. If perchance you have a situation where you're going to have to be above or have to go above 400 feet to avoid a collision, you can do that. You technically really don't have to actually report yourself, but you just be ready in case you do need to report. So what else can we say here? Okay, there will be 3 questions on the test on this specific question. And it'll be worded 3 different ways. The remote pilot is responsible for safe operation of the UAV at all times. Here's how they're going to word it to you. They're going to say, who's responsible for the safe operations of the UAV? A remote pilot, the FAA inspector, or the visual observer? Obviously, it's the remote pilot, but they're going to ask it a couple different questions. Who's the responsibility to make sure they file a flight plan or write a flight plan? And it's not so much that you have to follow it, but maybe writing one or knowing what your flight plan is. Who's responsible for the flight at all times, even though they may not be flying it? The remote pilot in charge is always responsible no matter what. What if you told the visual observer to do something? Who's still responsible? The remote pilot in charge is always responsible. So it's an important one. Let me think. Jake, is there anything you could think of off the top of your head in regards to questions about the remote pilot and any other? I know I had 3 questions on my test.
Yeah, I remember having one on making sure everybody's in a safe condition to perform their jobs, pretty much.
Yes, making sure that
That was the other one, I think. But I think you hit all the other ones that I saw. So.
Okay. They will say that you ask that, make sure you have a checklist and you are able to go through that. If you experience an emergency, you need to make sure that you figure out the best way to land your plane or your drone. The question, there might have been one question, not sure about this one. If you operate your drone over 400 feet, if you needed to make sure that you were in a safe to avoid an accident, you only need to report that if you were asked to. That's an important one too as well. We talked about language and NAVCOM radio. Oh, here's an important one. Okay. You will need to know the FAA phonetic alphabet. So I would do your best to put this in a memory. So Jake, I'm going to put you on the hot seat here. Can you spell your name in an FAA phonetic alphabet?
Well, the answers are right there, but Juliet, Alpha, Kilo, Echo.
Okay, excellent. Dwight, how about you?
Delta, Whiskey, India, Golf, Hotel, Tango.
Very good. Jason, you there?
Of course. Juliet, Alpha, come on, Argo, Sierra,
Ah,
Oscar,
fail.
and November.
Fail. There's no Argo in there.
Yeah.
Arco?
Argo. His
Is on
dog.
the red.
His dog is named Argo. There's no Argo. So, but I would make sure each one of you understand this. And a lot of people get confused about X-ray, Yankee, Zulu, Victor, uniform. Those are ones that are important. A lot of people try to do Apple instead of Alpha. A lot of people try to do some different ones for Foxtrot and golf. But
Right.
yeah, make sure. Make sure you get an idea on one of those. November, Mike are pretty easy ones. Lima is a difficult one, and Kilo is the ones that are hard to remember. But the rest of this should be pretty.
I would even put more stress. I think you have to memorize this. Absolutely. I mean, there's really no way around that.
Right.
It's you got to know the phonetic alphabet.
Yep, I agree.
How many questions are on this?
Well, I only had one.
Well,
Jake, did you have one?
it's
I didn't
But-
actually have any of these, which is kind of surprising. But I know it's
this
gonna be
is.
important. I know a lot of people have seen it.
You're gonna have to sip it.
I mean, if you try to file a NOTAM, for instance, there's a lot of dispatchers there that are taking that information from you. If you start calling it the Class B airspace, they're just going to shut you down.
Yeah.
I mean, right there. You have to memorize this. I mean, that's kind of the basis of aviation right there.
Right. Exactly right. Very good. Airport data, as we talked about before, the name of the airport, and then also here's your CT is your control tower frequency. Control tower frequency, CT 118.3. ATIS, that's your weather. ATIS right here is your automatic terminal information service right there. And then we get down here to Unicom. So this is basically your universal communication around that particular area. If the tower goes out, they might have notes, but the tower goes out, people use the Unicom frequency. Go from there. Okay. I think I might have had an elevation question, but that was about it. And then I did definitely. Oh, I had one of these. C. If perchance there is no Unicom, C indicates common traffic airport frequencies. So this is an important one to remember. If perchance the C is moved up, then I gotta remember how that worked. Star indicates operation part-time per foot tower frequency. So the end result is on the control tower will only be operating during these hours. After that, it switches over to the Unicom frequency. Okay, so it's important to notice this. Okay? Because I did have a question on that. Let's keep on moving on. Here's your Navcom radio. In locations where there is no control tower, I would recommend that everybody has a Navcom radio and basically is able to communicate on this particular one. You call out to the tower or to the area. It's called announcing into the blind and to the Unicom. You dial up the Unicom number. That's right here. The Unicom number here, 122.95. You dial that onto the radio, 1.95. You get the frequency. It'll show up right here. You push down on push the talk button. You'll say, hey, this is Foxtrot Alpha 12345. I'm a drone. I'm operating 200 feet southwest of the airport. I'll be no higher than 400 feet. Any traffic in the area, please advise. That simple. And I would make that announcement every 5 to 7 minutes, maybe 10 minutes at most, to making sure it's called self-announcing into the blind in your broadcasting. Okay. Airport data, we looked at this already. Unicom frequency and so forth. Go from there. Okay. Which one was that? FCM? Actually, that's Flying Cloud. That's the one near us. So you can take a look at that. We've already looked at that. We talked about that already. Uticom and multicom. So I think we're good. ATS, your weather information. Call in, list the weather. ATIS, the same thing. You are required to make sure that you communicate in such a way in non-towered airports, just like what I said, announcing into the blind. First step is radio procedures to identify the appropriate frequencies and announcing yourself in a Unicom frequency. Yep, this is exactly what we said, so it's very good. Yeah, broadcast in the blind, exactly what we said when you're for a pilot that's 10 miles out. Oh, here it is. This is November 324 Delta Mike, is 10 miles east inbound for landing, and I'll say Air Lake, Lakeville. Any traffic in the area, please advise. Okay. We're on the home stretch here. Usually I have another quiz. Additional resources for you. We happen to have the online learning center. We're going to give everybody access to the learning center. If you don't already, please use that for practice quests. There's 132 practice quests on there, and we're going to try to integrate this more into this particular talk too as well. Gowdy Brothers also provides an operation manual for all our clients, and for those that want to be clients, we can definitely provide that operation manual for you at a very reasonable cost. And then we have other resources that we talk about.
Steve, also on the when you talk about the online reading resource center, make sure you mention take some practice exams, guys.
Yeah.
Make sure that you understand the material. Go through the questions and just double check, because sometimes you feel really confident, other times you don't feel real confident. Going through this will reinforce it.
Oh, exactly. And we have I think we have over 500 people that are actually taking our online center right now. I think we're about like 700 people registered or something like that, Jason was saying. And then I think we actually now have, how many tests have been taken, Jason?
I think we're over 1,500.
1,500 practice tests have been taken on that online center. Truly amazing. So here's what we talked about. We talked about the regulations. We talked about airspace and the requirement to fly in them. We talked about weather. We talked about loading and performance of small aircraft. And we talked about the basic operations that are there. One thing that we want to finish up with, we want to make sure that you understand that if you refer any one of your friends to take this test, to take this workshop, we will give you guys a $25 gift, and or a $25. What are we going to call that, Jason?
Yeah, $25 gift for you and $25 off for your friend.
Okay.
Credit, you mean? A credit, Gowdy Brothers credit?
Or
Yeah,
a gift
that's
card
good.
or something. I don't know. We haven't quite figured out what we're going to do, but 25 to you and 25 to your friend. So that's a really great way to go. Thank you all for participating. Really do appreciate it. We will be sending out a survey and asking for your comments and feedback. If there's any questions that you've got right now, I'm more than happy to answer them. If it's more in-depth, please send me an email at info@Gowdy Brothers, and we're more than happy to get Will or myself to get back to you with that. Any questions?
Yay!
How much are you selling Yeah, thank you. How much are you selling the operations manual for? You mentioned that you sell that separately now.
It's for $1,500 and includes the Fast Start program. Everything's $1,500, Dwight. It's either 150, 350, or 1,500. So there we go.
I like to keep things
Well, you
simple.
made it down. You said it didn't cost very much. For a small price, you'll sell the operations manual is what you actually said.
It doesn't.
Right, 1,500 is a special deal.
Okay.
Actually, was Skyward sells theirs for 2,500 to 3,500. So I'd say it's.
And
Yeah, go ahead, Jason.
oh, I was just saying and up.
Oh, and up. Yeah, right. That's just for the introductory piece. There's another 2,500 module that you add on to that, and then another 2,500 if you want all the bells and whistles. So yeah, it gets pretty expensive.
I do think, Steve, just a housekeeping item. I do think maybe what we ought to try is telling everybody, hey, we're going to keep your mic live, but if you could mute it yourself, and then whenever you do want to talk,
That's probably the best way to go.
because I think people are comfortable around on conference calls. Most people will voluntarily mute themselves, and I think if we tell them, please mute yourself, so we can mute you, but we want you to have the opportunity to break in if you really have some question. And I think maybe that might be something we could try.
Mm-hmm. Okay, that sounds good. Very good. Okay, we did. Okay, I think I spent a little more time on maps. I'm going to clean up some of those maps and kind of do some of the things I think I did before. I got to remember, Jake and I need to get together and kind of pick out some of those ones that he can remember. If we can send Luke to go take the test, or maybe even Will can go take the test, then we can kind of pick out some of these map questions so we know exactly what they are. I want to make sure we get all 30 of them if we can. And so
Yeah, I think the maps are the most scary part for people. I think people are most intimidated by that aspect, and it doesn't have to be very intimidating. And actually, I think when people can see and have a whole bunch of examples like you just went through, I really think that's going to increase their confidence level and give them a lot of valuable information. But most importantly, give them the ability to look up and figure out what that means. That I think those showing them how to figure out and what to associate with, I think that's really going to be key here.
I had a lot of questions on map 70, 71, 70, and 74, and so I guess I got to just make sure which ones we had questions on and see if I can replicate those. I'm going to try to pull more questions from the Jake's Learning Center so we can kind of
Incorporate them in.
yeah, I think so. It'd be good.
If you want to use the actual questions, Steve, just go to the question bank that you have access to and pull those questions out of there.
Yeah, I should probably just go right to that website and go from there. That'd be good. I think we're going to do that.
That way there's not, was that the question that I was asked? And because there's so many questions in there, you're really not ever going to remember exactly which one it was. So if you just go to the question bank and just pull those questions straight out of there, then you have that. You could get this question, or you might get a different question, but it's going to be the same thing.
Right. Yeah, very good. Okay, excellent. Okay, any other input from our attendees? Dwight, Jake, or Josh? Or Joy?
I hate to do this, but Steve, could you go to the last slide?
Yeah.
Like the one before this one? I think referrals is 2 R's and 1 F. And sorry about that.
Thank you.
Don't be sorry.
I'm just a spelling Nazi sometimes, so.
Hey, Jake, I got to take credit for that too.
Was that you, Jason?
That was me. Oh, good catch.
Oh, man.
That's not good.
Is that it? Referrals?
Yeah, that looks good.
Okay. Excellent. Thank you. Spelling Nazi. I love it. Okay. Very good.
Very helpful to get the spelling correct.
Okay, so Jake, one of these times we're gonna have to kind of pick your brain again and see if we can remember some of those what sectional pictures were on there. As the days go by, I'm starting to forget some of the questions and so forth. We're definitely
absolutely. I got as many down onto the website as I could.
Okay.
But yeah, we could definitely go over some stuff, and maybe some questions would come back to mind. So.
Well, I might just incorporate those, just like Will was saying, incorporate some of those questions in the Learning Center into here, make it real simple so we're kind of like we're from live stuff. If I can get Luke to go, he's the best one out of all of us. He's got a photographic memory. He can go and memorize all 60 of them and come back and just tell them what they are, at least from the test he took. So
that'd be sweet.
Well, Jason, what are you doing?
Sorry, I had myself on mute. I was wondering. I think one thing that would be valuable is putting a lamp or something in front of you, and getting a little bit more light on you.
Oh,
It
yeah.
just looks like you're sitting in a dark room illuminated only by the aura of your screen.
Lights in the room.
Yeah.
Okay, yeah, we could do that. There's not,
I mean,
it's
it's not bad. It's really not bad. I'm being extra critical.
don't worry about it.
but,
We'll do it next time.
No, that's why you had it muted, Steve. It's terrible.
Yes.
Oh, wait a minute.
Okay, guys, I'm gonna let everybody go. I'm gonna say goodbye to my daughter. Joy, are you still there?
See you guys.
I love you.
See ya.
Hey, Jason, have a great trip. Have a wonderful time.
Yeah, well, we'll talk.
Okay, that sounds
Hey,
good.
Jason, I'm going to give you a call right now if you have about 10 minutes.
Okay.
I
Okay,
have about
thank
5
you very much.
minutes, but
Jake, thank you very much. Josh, thank you very much. Dwight, thank you very much. If you want to talk,
Joy.
I said-
Thank you.
So, if you guys have any feedback to us later, give me a call offline, and we'll talk tomorrow. Thank you very much, everyone.
Hey, everybody.
Okay,
Thanks.
all done. Yep, thanks.
Good night.
Steve.
Bye. Good night.
Is this a better light?